62?
No.
Okay. When I'm looking at this, whenever I have a simplified problem, and I have multiple variables, and I have also a bunch of numbers, the one thing that I always try to do is I always want to take care of my numbers first. Now, in this case, whenever I have that, I'm going to put my fraction bar back in. I may or may not need it, depending on what the problem winds up to be. But right now I have the amount 5 over 20. What does that simplify to? 1/4. So I write that in 1 over 4. Now I go variable by variable using the rules. And what I was talking about yesterday in the video was that whole game of war. And I'm looking at the 3 and the 2 with the x's. The 3 wins. Now, where is the 3? Is it the numerator or denominator? It's the numerator. So since the 3 wins and it's in the numerator, your answer is going to stay in the numerator. So what's 3 minus 2? 1. In essence, what you are also doing is this. X cubed is x, x, and x. Do you agree? X squared is x times x. What drops out? Those drop out. Pairs of 1 cancel themselves out. That's what you're doing in shorthand version by saying who wins in the game of war. Now I've taken care of my x variables, I go to the y's. In the y's, I have y to the 9th and y to the negative 2. Now, negative's not happy there, is it?
No.
Where will it be happy? On top. So I'm just going to do this for a second, 9 and 2. Now, I know that some of you guys might be able to just do that one step and rewrite it, but it's okay just to send it up and take an extra second. Remember, if an exponent is negative, it's not happy where it's at. It switches to the other side. There's only 2 sides to a fraction. Numerator and denominator. There's a fine line between them. Did I get a boo?
Said no, I didn't see
I thought you said boo. With your really ecstatic face. Boo. Yeah. I get it. I'm not funny. Ah!
Oh, and then you do that silly face. That means, oh, it's not really funny. Yeah, because he's so. I'm just getting my jokes swag through bread. Yeah.
That's me. Yes, Hank. Does that clear that one up? Same one? I mean, same section? I want to say in 6-1 right now. Yes, sir. 40?
Oh, no, before you leave this one.
Can you go back to that last one?
Yeah. Oops.
Okay, how do you, wait, how did you get the, wait, how did it make the coefficient? Time out. Oh, it's just, do you have to write the 1?
No, you don't. You just write x, y to the 11th over 4. That's fine.
Okay.
When I first did that, remember I had 5 over 4, we said it was 1/4. What he's asking here, guys, is do we have to have the 1 there? You don't. It's not a big deal.
What if you write it as 1/4 xy?
That's fine.
Okay.
That's fine. That works.
I wrote x to the power of 1.
That's fine.
Alright.
You just wasted pencil there.
Yeah. It's a habit. It's a bad habit.
That's a whole bunch of junk that's negative, isn't it? To a negative exponent, excuse me. It's not happy where it is. Where's all that junk going to be happy? In the denominator. So we just rewrite it as 1 over 10x to the 3rd, y to the 5th, all cubed. Now I have to use my distributive power property, I don't think that's what it's called, but you get the idea, where I have to distribute this cubed term to all 3 here. So I get 1 over 10 cubed. Y to the 3rd, I'm going power to power, which means I have to multiply. So I get 9. And then 5th to the 3rd, I multiply again, I get 15. And I hope that you rewrote that as 1,000. And that's it.
Wait,
I just
1,000.
Do you have to write it as 1,000?
It's not the end of the world.
1,000 x to the negative.
Yes, sir.
Why isn't it x to the negative?
If you distributed first and you wrote 10 to the negative third, x to the negative 9, y to the negative 15, now none of those are happy. So you get 1 over 10 cubed, x to the 9, y to the 15.
So when you
Oh.
All I'm doing is, since it's all junk that's not happy, I made it all happy first.
That's when it's up top and then you put it down.
Yep. Yes, sir.
Don't you have to rewrite it as like y15, 9, or to x to the 9th power and 10 to the 3rd if you're going to do the x or the rules or whatever that we learned yesterday?
You don't have to. I mean, you don't have to show that you're going x to the third to the third. You don't have to show that step. I'm not.
No, I meant like in like decreasing order.
Oh no! Oh no! Wait, I know what you mean. Decreasing order is only when you're dealing with polynomials. This is just a simplified problem. You just put numbers first, and then I usually just go alphabetically. That's not a big deal.
46.
I think it's similar to this. Oh yeah. You know why? How many of you, be honest, cross multiplied?
I didn't know. I didn't think you could.
You can't, and I already yelled at you for that. You can't cross multiply for that because do you see an equal sign?
No.
No. So what you do is you multiply it straight across, guys.
I didn't.
When you multiply straight across on this, I would just rewrite
Can't you just rewrite it all as one?
20x to the 20x to the 14th, y to the 10th
Yeah.
over 2. I have x cubed times an x. What does that become? X to the 4th, and then y to the 6th. What I did there is just rearranged everything, because remember, order in multiplying doesn't matter. And I lined them all up, and now I go numbers first. What's 20 over 2?
10,
Who wins, 14 or a 4?
14.
It's 14 minus 4.
Is that the thing for that? 14 would be like a joke.
And then 10 into 6, we get y to the 3.
So you can't do it first and then multiply it?
You can if you want. If you want to simplify first. I'm a creature of habit, and I put my numbers in order first, and then I simplify from there. That way I don't miss something. That's all. I try not to do too much at once. Okay. What about 6.2?
I actually like it.
Is that
Not
division?
gonna lie, I like it.
Good. That's really where we spend a lot more time with polynomials. In 6.2,
Can you flash us the answer? Is there a
yeah, I can run through them here real quick, Frank. What I want to remind you guys of when you're doing synthetic division, and I have an example I just want to show you to make sure that you got this one right.
Was it the adding not the exponents that aren't there?
Yes.
I didn't do that.
I want to look at 36 real fast.
Okay.
And there's a little bit of a trick involved with these things.
We didn't have to do 36.
I know, but I'm showing you it anyway. There's a little bit of a trick involved when you're dealing with properties, when you're doing synthetic division with polynomials. Do you guys remember what it meant to ask, when someone asks you what's the degree of the polynomial? Remember what that meant?
Yeah.
What is it called?
How many different levels of exponent there are?
Close. It's what's the highest level of the exponent? What's the highest level of exponent in here? It's a 5th degree polynomial. Okay? If it's a 5th degree polynomial, that means I'm going to have 6 values for synthetic division. I have 5th power, 4th power, 3rd power, 2nd power, regular, and a constant. So I'm going to have 6 values. So when you're doing your synthetic division, one of the things to remind you is whatever the highest degree is, you will always have one more in this first row. That's where people usually forget that 0 for the constant at the end, or somewhere in the middle. Okay? So you pull your exponents out, or your coefficients, so you have -1, a 0, -4, a 6, -1, and a 0.
That means I definitely got them wrong if I didn't do those.
Yeah, you will have got them wrong if you do the zeros. You have to have those placeholders.
So those, that's like in an equation or something? Or how
That's just the rule.
Like where? How do you know where to put the zero?
You put them in the descending order. If you look again, if I have a fifth degree polynomial, the first one is x to the fifth, the next one is the x to the fourth, the next one is x to the third,
Oh,
x
okay.
squared, x,
I never
and then the
looked at it
constant.
that way.
When I'm working my way down, I'm plucking all the coefficients out to make that work. If I don't have one of those values in the actual equation itself, it becomes a zero. All right? But in all honesty, you got the crux of the idea of how to use this stuff. It's just you miss a couple of zeros.
It's not like the worth of this thing, you get it?
That was good. I'll give him that one. Remember, drop the first term down. Yes, ma'am. Drop the first one down, and then you multiply in. -2 and -1 is 2. We add working down. We multiply across. We add. We multiply. We add. We multiply. And we add. And you're done. Okay? Okay. Oh, I thought it was -10. I'm sorry. I got lost in my handwriting. Sorry about that. Yeah. And this is, what, 90? Sorry. I got lost in my handwriting. I thought it was a -10 there. It happens. What number? Sorry, I didn't get you to miss yawn. 64?
I think they're both.
64, we're talking about end behavior. When we're dealing with end behavior, that means what we want to start out by looking at is the graphing on the graphing calculators. So this one's a 4th degree polynomial. In the graphing calculator, I'm guessing it probably has like a W shape to it. It's got a W shape to it, and the first term is positive. Do you agree?
Yeah.
Okay. So if the first term is positive, it's got a W shape to it, it probably does something like this. Okay, I was wrong.
Well, it's like there,
It's,
it looks like there's W shape, but it's just one of the
It's what
minimums
you
is
get.
really far down out of the limit.
Oh yeah, it's almost like a direct line up, right?
It looks like it's a V. Not really. It's
Like
like
a chair.
No,
Yeah. No, Mr.
Well,
Murphy.
no.
It's like this.
Yeah,
What about that one that
Like
like
takes
this?
a direct line up.
It's
Get
like
your calculator half.
down and then it
takes too long. She knows what it looks like.
But it goes farther.
Oh what?
Oh, no.
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 Boo.
No, it's fine.
Yeah,
All right, it's fine. Now, does it matter what's going on in the middle here?
Not really.
No. The only thing that matters here is what's going on at the ends. When you look at what's going on the outside, where things are going towards, as x is getting larger and larger and larger, what's happening to the y values? They're getting larger and larger. So as x is getting larger, f of x is getting larger. So what they say is, as x is approaching positive infinity, f of x is also approaching positive infinity. Yeah.
So you only go by the two tails.
I'm only looking at the tails.
Point.
I'm only looking at the tails because at this, when we get into this more later on, we're going to look at these values more. This one would be what we would call localized minimum, and this is a change in direction. We'll get into more and more of that as we go on, as we keep graphing. You're only looking at tail ends.
So when x is negative infinity,
What's that?
when x is negative infinity, f of x is negative infinity?
Correct. Yep. It's not when it is, it's when it's approaching.
Yeah.
Okay. Yes, sir.
So what about the left side, reaching negative infinity?
That means the f of x is, I'm sorry, I misspoke there. As x is getting smaller and smaller, the y values are still getting larger and larger, so it would be going a positive infinity. Okay.
So x hits either infinity, y hits constant.
Right. Okay. What else?
So do you see if you turn
Cut it out.
Do you
Grow
see
up.
the- It's a mouse if you turn it sideways.
Grow up. Yes, sir.
That's hilarious. I have the answers for,
Oh, this is that it?
Yeah.
Yeah.
Going on.
Synthetic answers, let's see.
Oh yeah, I definitely got all of it. Is this the one where you had to add in the 0?
Yeah.
Yeah.
Starting at 38.
Yeah.
38, we get negative
22.
22.
Oh. All right, there's one.
40, we get uno.
The zeros aren't even affecting it yet.
Because we haven't like
Because you haven't had an issue yet with those.
Oh.
They're already all in descending order with no missing values. 42, I get a negative
Oh.
104.
Oh, very different actually. Don't change your answer.
44, you get 90.
Oh my goodness.
Add the 0. That's
And then 46 get negative 110.
Oh, we were really close.
You gotta add
Or you would associate it. Yeah, they're you just typed it in wrong. When you're looking at the word problem on that one,
What was the negative? 46
it tells you it gives you your function and tells you the time starts at 1983, or excuse me, 1980. If the time is, we're trying to figure out from 1983, that means the t value is only 3. You substitute in 3 for that, and it'll spit out the answer for you.
Is it by any chance $8.55?
It is by chance. It's $8.55. The easiest way to do that, if your value is an integer, if they're asking you what is if the t is equal to 3, put that function into your graphing calculator, your y equals, and go to your table, and it'll get it for you. It's a lot easier than trying to worry about if you missed a sign here or there, but if you type it straight through without parentheses, you don't have to worry about it. Okay? Anytime it's asking for a direct substitution style like that, go to the table. It's a lot quicker. You could, yeah, if you want. All right. Make sure your names are on that, and then let's talk 6-3.
So all you have to do is type that thing in and you're going to just
Usually
look
when
where the t value would be.
You know what you're talking about.
I didn't even think about it. That's crazy.
Wait, Mr. Murphy, what were the numbers for that homework? I wasn't here.
You didn't write it down?
No.
Can you read his chicken scratch? Can you read Leaves? All right, 6-3. Adding, subtracting, and multiplying polynomials. This is a section that I do know for certain that you have done. I do know for certain that it does not take long to go through and master. So,
Jack must have tried throwing ways.
so what I'm looking at here is I'm going to give you guys a couple of tips and a couple of tricks as far as how to set these problems up in such a way that it makes sense every time. What happens a lot of times in the book, when you're looking at the problems in the book writes all these things out horizontally. I have found that whenever you're adding or subtracting when you're working with the math stuff, it's always easier to visualize what's going on when you rewrite it vertically. Here's what we're doing. When you're adding or subtracting, you're doing nothing more than combining like terms. The easiest way to combine like terms is to match them up with the same coefficient and same variable. So whenever you see a problem written out like this, what I'd like you to get in the habit of doing is just rewriting it automatically, 3x cubed, in descending order. Put zeros in if you have to have a placeholder. And then in the next part, just match them all up. I have an x cubed minus a 10x squared plus an 8. What goes in the value for the x? A 0. What I'm doing here is I'm putting a placeholder in that spot so that way I don't screw anything up. Okay? This is an addition problem. It's a third degree polynomial, which means I'm going to have 4 things to add together. So I'm adding between all of these. This is where it gets real tricky. Ready? 3 plus 1.
4.
2 plus negative 10.
Negative 8.
Negative 1 plus 0.
Negative 1.
Negative 7 plus 8.
Oh, so you literally just combine the like terms.
That's all you're doing.
Oh, I like.
For addition, it's nothing more than combined like terms. You guys are all, you've all done this, and you've done this many, 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 many different ways, many different times.
So you don't have to have the same.
You're matching up same coefficient with same, or no, I'm sorry, same variable with the same exponent. That's the only thing you have to worry about when you're adding or subtracting. Addition problems, they're a piece of cake. It's the subtraction problems that you guys tend to make issues with because you've got to worry about all your signs. For example,
Oh yeah, keep looking.
yeah, let's look at the second one here. I have 9x to the fourth. And when you're writing the problem out, write it right away as a vertical setup. We have 9x to the fourth minus 12x cubed plus x squared minus 8.
Oh dear. Oh.
And then I'm going to subtract from that 3x to the fourth, a negative 12x cubed, and a negative x. So once again, when I'm starting to write these out, I go write some vertically. Yeah.
Do you think it's easier to distribute the negative first?
No.
Harder.
You're going to miss a sign. If you do it this way, I'm going to show you. You might be pleasantly surprised at where I'm headed here.
Okay.
We start by just putting things in your descending order. If it's a fourth degree polynomial, how many terms should I have?
5.
Good. Since I don't have an x term, what should I put in there?
0.
Put an ox.
Is that minus
No x.
I guess. I thought it was funny. Personally, I thought it was very
I'm just
funny,
not. I'm
actually.
full of something. It's not funny though. That was bad. And then lastly, just match up with what you have. We have a 3x to the fourth minus a 12x cubed, and then I have a 0x squared. I have a minus x, and I have a plus 0. Now I have 5 terms in the new, or I won't say numerator, 5 terms on one equation, 5 terms on the other. How many subtraction signs am I going to have?
5. No. Yeah.
You have now created 5 subtraction problems. 9 minus 3.
6.
Negative 12 minus negative 12. 0. 1 minus 0.
1.
0 minus negative 1. Negative 8 minus 0. And again, the reason why I did not distribute that negative to all those terms is that way I can line it up and have those written out as separate subtraction problems. The mistake you guys are going to make is something stupid in here. You know, something, certainly did. Something stupid in that general area. You're going to accidentally forget to flip your sign around. Yeah, you're going to write negative 24 or 24. Just be careful. If it happens to be one of the things that you tend to do from time to time, take a second on the calculator, just do negative 12 minus negative 12, and you won't get it wrong. Yes, sir?
I just want to share this with the class, but just so no one feels bad, I actually messed one of those up just now.
Well, I appreciate you being honest here. And it's true. It's
That happened to one of them, but not a lot.
he's looking for a hug from somebody, I think, to say that he's not the only one that made a mistake.
That's hilarious. That's fun stuff.
Taking ownership.
Hilarious.
But you see where I'm going at on here, guys? Just slow down. The other part of this stuff also deals with when you have to multiply. I'm going to write this so you can see it better.
Boil it out or what do you?
Oh, whoa, whoa!
Whoa, Nelly.
I can't foil that. Why?
Because it's not different amounts of them, right?
Okay. It's not the same amount. Foiling only works when it's binomial. 2 terms times 2 terms.
Yeah, I should
In this case, I can't. Yes, sir.
It's like a matrices, columns don't.
Yeah, I can't do that. Yeah. In this case now, all this becomes is a distribution problem. You have to distribute twice,
That's,
okay?
unless, what if there was 4 and
Then you have to distribute 4 or 5 times. You've got it, and you just have to pay attention to what you're distributing out to. You'll have to use some of your exponent rules. You know, when you're multiplying in with exponents, watch out if you have to add them together. And then at the very end, it's combining like terms. So I would distribute to all 3. I get 3x cubed minus 2x squared minus 4x. And then I got to distribute the negative 3 to all 3 of them as well. The mistake you will make here is if you have to distribute a negative value, you tend to distribute the negative once, and then the other times you'll distribute it as a positive value, so you forget that it was a negative. Just pay attention if you have a negative value. Remember that you're negative 3 times positive, so it's negative 9x squared.
A good tip.
Negative 3, negative 2, and then you have a positive. That's,
Do you think it'd be a good tip if you, so after you did negative 3 times 3x squared, maybe if you went back and looked at it for maybe 2 seconds, like a whole 2 seconds, just to see it in your brain again, just every time refresh that, whole 2 seconds.
would not be a bad idea.
Alright. Or you can whisper it to yourself, that's a very good tip.
And then lastly, it's combining like terms. Remember, when you're done with these problems, you always want to put them in a descending order. Oops. So we have a 3x cubed. One other suggestion I will make when you're doing your combining of like terms, if you're done with one of the higher powers, especially if you've got a long string of these, cross it out. That way you know you don't have to worry about it later. Then you have negative 2 and negative 9. Negative 4 and positive 6, and then a positive 12. I know you have seen those before. It's just a refresher of what do you do. Okay? Remember, you're just using distributive property a couple of times. Okay? The other weird one is, get to this one here. I have 3 terms. I have 3 terms, 3 binomials. I can't FOIL this, but I could turn this into an easier problem to work with, couldn't I?
Yeah, you could.
If I FOIL 2 of them and then do a distributive property for get the third, that's what you would do. What I mean here is, if I have 3 terms like this, x minus 2, x minus 1, x plus 3, I pick 2 of them. Doesn't matter which ones.
Yeah, do those.
I FOIL that. I get x squared plus 3x minus x minus 3. Rewrite x squared 2x minus 3. And I have to multiply that by x minus 2. It just takes a second longer to do. Okay? And then you just distribute out again. All right? Once again, it doesn't matter which ones you choose to start with. You're going to get the same result if you do it right.
Oh.
Okay. But the one thing I do want to remind you guys of that so many people have problems with is 3 and negative 1. The one part that most people get wrong. What does that equal?
X squared plus
X squared
4x plus 4.
What was it? Wrong!
Don't
You're
say that.
This, guys, that's jump squared, isn't it?
It is, so it's just x plus 2.
It's jump squared. Jump squared is jump
Times jump.
times jump.
Well, times a jump, but
Okay? You cannot distribute into here. Why? Because there's a plus sign.
telling you why.
I was just using
You
that.
can't do that.
Wait, why?
You can't distribute over addition.
Why's that?
Because there's one.
just do like x squared.
What happens here, guys?
Oh, because you would have to do that.
What a squared term means is that you're multiplying it by itself twice. You're not distributing in. Okay?
But subtraction.
You cannot.
Oh, you
It doesn't matter
add
if
a
it's
negative exponent?
if it's junk squared, no matter what it is, it's junk squared. It's junk times junk. Okay? You have to get that through because Mr. Tames will beat me up if you guys get that wrong next year. Okay? I can run faster than him, but you might get me sooner or
Do you
later.
guys ever box on weekdays?
And I'm jokingly about a lot of that here. But guys, I've been saying a lot of times when you see stuff squared, it's junk times junk. And I know a lot of you guys, when we did solving equations with square roots and stuff like that, there were times where you guys had a problem where it was 3 times the quantity x minus 2 squared, and you guys were writing this out as 3x squared minus 12. It's wrong, guys. It's not even close. Okay? This is not even close to that. You guys were doing that a lot. And I kept telling you, junk squared is junk times junk. If it takes the idea of making sure anytime you see that out with the square term, please, 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 please write it out twice. Okay? Please. Yeah. That would be, this would have equaled 3 times x squared minus 4x plus 4. When you FOILed it, then you'd get 3x squared minus 12x plus 4. You would have done that. Okay? It's one of those things that you guys tend to screw up a lot. Remember, junk squared is just not junk. I want you to do on page 341.
I'm excited for this one. I like it. Kids who like homework. Fresh. Sorry, yeah. What?
9 problems, guys. Add, subtract, multiply. Okay? 9 problems.
Wait, all even? Oh, that's funny because
Okay?
that works. Mr. Murphy, where'd you learn that trick? Mr. Murphy, because it's almost like you're dashing like each of them and you're like saying they're all evens, except the bottom one you put a little too low.